Process Safety and Risk Management in Chemical Engineering. Presented by Engineer WahajFaisal. Key definitions. Risk: a combination of likelihood and consequence of a hazardous event leading to an accident. Hazard: inherent physical or chemical characteristic with potential for causing harm to people, environment, and property. Process hazard: uncontrolled interaction of material and energy, resulting in harm. These terms are fundamental to understanding and managing safety in chemical processes. Common hazard categories. Physical hazards: electrical shocks, radiation, high temperature, pressure, working at height, and noise. Chemical hazards: flammable, explosive, toxic, reactive, corrosive materials, fumes, gases. Biological hazards: microorganisms, infections, hospital, laboratory waste, airborne, waterborne diseases. Ergonomic hazards: poor work design, long sitting hours, stress, poor lighting, and inadequate rest cycles. Psychological hazards: factors contributing to mental stress or strain in the workplace. Accident causation: 1. Unsafe conditions. Circumstances in the industry that can lead to an accident, e.g., poor housekeeping, unsafe equipment. 2. Unsafe acts. When workers ignore or are unaware of standard operating procedures or safe practices, e.g., carelessness, not using pay. 3. Basic causes. Invisible underlying factors like human factors or uncontrolled material, energy interactions. The majority of accidents are due to unsafe acts, highlighting the importance of human behavior in safety. Accident, incident, and near miss. 1. Accident: unwanted, unforeseen, unplanned event resulting in loss. 2. Incident: unwanted, unforeseen, unplanned event with potential to cause harm. 3. Near miss: an unplanned event that did not result in injury, illness, or damage 3 but had the potential to do so. Every accident is an incident, but not every incident is an accident. Focusing on incidents reduces overall risks. Safety pyramid: proactive vs reactive efforts. The safety pyramid illustrates that proactive efforts at the base, addressing unsafe acts, conditions, are crucial to prevent major accidents and fatalities at the top. Reducing the gap in thinking, knowledge, and implementation through management systems leads to a safer workplace. Why invest in safety? Moral or humanitarian? Ethical and professional responsibility to ensure safe workplaces and processes. Legal compliance: avoid criminal and civil liabilities from accidents. Economic benefits: safety is an investment, not an expenditure. Indirect costs of accidents far outweigh direct costs. Investing in safety is good business, leading to significant savings and improved corporate image. Safety as layers of protection. Community emergency response. External response for large-scale incidents. Plant emergency response. On-site team for immediate accident mitigation. Physical protections. Dikes, containment, and other physical barriers. Safety instrument systems, SIS. Emergency shutdown systems for critical control. Critical alarms or manual intervention. Alerts and human action to prevent escalation. Basic process control. Handles small deviations and ensures smooth operation. Safety in design. Inherent safety measures are integrated from the start. Safety is built in layers, from initial design to emergency response, to contain hazards and prevent exposure. Iceberg of accident costs. Direct costs, medical, wages, are only 10% of the total. Indirect costs, production loss, litigation, image damage, are 16 to 75 times higher, making safety a sound business investment. Process Safety Management, PSM. PSM is the application of management controls to identify, understand, document, and control process hazards. 1. Technology. Process Safety Information, PHA or Operating Procedures. Management of technology change. 2. Facility. Quality assurance. Pre-startup safety review, mechanical integrity. Management of facility change. 3. Personnel. Contractor management. Training or auditing. Incident investigation. Process risk assessment steps. Define system or objectives. Establish scope and goals, including process safety information. Hazard identification. Determine what can go wrong using techniques like HAZOP or FMEA. Accident modeling. Assess how bad it can go wrong. Consequence estimation. Frequency estimation. Determine how often it can go wrong. Likelihood. Risk quantification or evaluation. Combine consequence and frequency and compare to acceptable risk. Risk treatment or optimization. Develop and implement plans to reduce risk, ensuring no new risks.